In this video, I'm going to show you how to solve word problems on the topic of speed, distance, and time, where we have to solve for an unknown time. The key to these problems is to remember that distance equals speed times time. Let's read the problem and fill in our table as we go. A student attends college 1,200 miles away from home. So distance, that's a distance right there. When classes started in the fall, the student flew there on a plane at 500 miles per hour. That is a speed, so let's underline that. But on the way home in the spring, the student carpooled with friends driving at 60 miles per hour. There's another speed. How much longer did it take the student to drive home than to fly to college? So driving and flying are methods of transportation here. Let's write fly here and drive. And our distance in both cases is 1,200 miles. So write 1,200 in both boxes. And keep note that's in miles. Our speeds are different for the two modes of transportation. Flying is 500 miles per hour. And driving is 60 miles per hour. Keep note that we're in miles per hour. And then time, that's what we want to find. We want to find how much longer did it take to drive than to fly. So that's just the difference in times. So let's figure out what our times are here. First of all, let's get our units straight. We're in miles for distance. Speed is distance over time, so time is hours. Now let's set up an equation, two equations that we can solve for time. First of all, let's solve for time flying. So in flying, we have the equation distance equals speed times time. So 1,200 equals 500 times time. And if we divide both sides by 500, we get 12 over 5 equals time. We can simplify that to a mixed number. 2 and 2/5 equals time. We'll plug that in the table. 2 and 2/5. So it takes 2 and 2/5 of an hour to fly to college in the fall. Now how about driving? Let's set up the same distance equals speed times time. Distance equals speed times time, and let's plug in our information. So distance again is 1,200, and then speed this time is 60 times time. Okay, now we divide both sides by 60 and we get 20 equals time. So 20 hours is how long it takes to drive back. And then our question asks for how much longer. Well, that's just the driving time minus the flying time. So that's 20 minus 2 and 2/5, which is equal to 17 and 3/5. And remember that's in hours, that's our unit, hours. We can convert that even to be a little bit more nice. We can convert that as 17 hours, and 3/5 of an hour is, well, 1/5 of an hour is 1/5 of 60, which is 12 minutes, so 3/5 is 36 minutes. So that's our solution. That's how much longer it took to drive than to fly. Here's another example. So let's read this problem statement and pick out the distance and the time. So two gigantic football players are located 15 yards apart. There's a distance on opposing teams. As soon as play begins, they run towards each other. If one player runs at a speed of 6 yards per second, there's a speed, and the other at a speed of 4 yards per second, there's another speed. then how long does it take for them to collide? Well, let's draw up a little diagram of what's happening. So we've got two football players, and initially they're at a distance of 15 yards, and one of them is running at 6 yards per second, and the other one is running at 4 yards per second. And we want to find how long does it take for them to collide. Well, they collide when the distance between them is 0. So we have to find at what time is the distance between equal to 0. So the distance between is decreasing according to their combined speed. When this player runs 4 yards and that player runs 6 yards, the distance shrinks by a total of 10 yards. So we have to add the players' speeds to see how fast the distance is decreasing. So let's write combined speed. That's equal to the first player, 6 yards per second, plus the second player's speed, 4 yards per second, for a total of 10 yards per second. And now we can use our master equation. Distance equals speed times time. And plug in our numbers here to solve for time. Let's also keep track of our units. Distance is in yards, and speed is in yards per second. So time has to be in seconds. All right, we're ready to plug it in. Distance is 15 yards. So 15 equals speed. Our combined speed is 10 yards per second times time. And to solve for time, we just need to divide both sides by 10. So 1.5 equals time. And then looking at our units, time is in seconds. So 1.5 seconds is how long it takes for the players to collide. Here's our final example. In this example, we're in gym class and a student brags that they're the fastest animal on earth because they can run a mile in 6 minutes. So to prove that the student is wrong, the gym teacher allows the student to race against the school mascot, who is a dog named Barkley, who runs 30 miles per hour. If the race takes place on a quarter-mile track, how long is it before Barkley laps the student? So we've got the case of a student racing against Barkley. So let's make each one have a row in the table. Top row can be Barkley, and the bottom row can be student. And we want to find how long does it take for Barkley to lap the student. So that's really just asking when is Barkley's distance minus the student's distance equal to 1/4 of a mile. We want to find where Barkley is 1 lap ahead of the student, and each lap around the track is a quarter mile. So we want to find where Barkley is a quarter mile ahead of the student. So we want to find where Barkley minus student distance is equal to 1/4. Let's keep in mind our distance is in miles, so we'll put the units up there. And let's go back and find, let's fill in the table with what information we have in the passage. So for Barkley, we have that Barkley runs at 30 miles per hour, and the student, we have that the student runs a mile in 6 minutes. Before we fill in the table, we should keep these to have the same units. So I think it's going to be easiest if we use miles per minute here, because Barkley's probably going to lap the student in a matter of minutes rather than a matter of hours. So student, a 1 mile in 6 minutes, that's like 1/6 mile per minute. Put our units here. Mile per minute. And then to convert Barclay's speed to miles per minute, we'll start out with 30 miles per hour, and then times, we want to get rid of that hours, turn it into minutes, so we got to times by hours over minutes, and in 1 hour there's 60 minutes. That way we've got 30 over 60, which is 1/2 mile per minute. So let's fill our table with 1/2. And now we can, we need, we don't have time, we don't have distance, but let's create a variable for time, because we're comparing the speeds at the same time for both Barclay and the student. So we can just make that t for both Barclay and the student, and time is in minutes. We'll keep note of that. And then the distance here, Barclay's distance is then 1/2 times t, and student's distance is 1/6 times t. Now we're ready to plug this information into our master equation here. We can say that Barclay's distance is 1/2 times t, and then minus the student's distance. Student's distance is 1/6 times t, equals 1/4. And then we're there, we can solve it. So 1/2 minus 1/6, 1/2 is like 3/6, then minus 1/6, that's 2/6. So 1/3 t equals 1/4, and then t equals 3/4. Our time is in minutes, so t equals 3/4 minute. In other words, a quarter of a minute is 15 seconds, so the time is just 45 seconds. So in just 45 seconds, Barclay is able to lap the student. As we saw in these examples, the key to solving these problems is to remember that distance equals speed times time. If we need to solve for an unknown time, then we can pick out the speed and distance from the problem statement and then set up an equation to solve for time.